Example 28. Example 28 says to calculate the volume generated when the region bounded by the curve y squared is equal to 27x and y is equal to x squared is rotated through 360 degrees about the y-axis. So important to note here is that this rotation is not about the x but about the y-axis. All right, whenever we're trying to determine the volume when when the area bounded by two curves is generated about an axis, one of the first things we need to do is to determine the points of intersection. So we're looking at the points of intersection. Now, at the point of intersection of two graphs, both the x-coordinates and the y-coordinates are the same. So y for one graph, which is the root of 27x, will be equal to y for the next graph, which is x squared. Now, to solve this, let's square both sides. If I square both sides, I'm going to get to 27x is equal to x to the 4. So now I have x to the 4 minus 27x is equal to 0. X is common, so I have x into x cubed minus 27 is equal to 0. Now I have x into x minus 3. X cubed minus 27 is the difference of 2 cubed. And this is x squared plus 3x plus 9 is equal to 0. Therefore, x is equal to 0, or x minus 3 is equal to 0, or x squared plus 3x plus 9 is equal to 0. Therefore, x is equal to 0, or x is equal to 3, or x is equal to. So to find the other values of x at the point of intersection of the two curves, I need to solve this equation. It's a quadratic equation, and it cannot be factorized because there are no two values of 9. There are no two factors of 9 that can give you 3. So therefore, I have to try and solve it using the quadratic formula, which says that x is equal to minus b plus or minus the square root of b squared minus 4 times a1 times c, which is 9, all over 2 times a, which is 1. Now, if you look carefully, you can see that the roots of this quadratic equation are imaginary because 3 squared is 9, and 4 times 1 times 9 is 36. So therefore, 9 minus 36 is negative, and you can't find the square root of a negative number or the solution to this equation, this quadratic equation, would be imaginary. So the only two values of x we have are x is equal to 0 and x is equal to 3. Now we have the values of x, and we're also going to need the values of y at the point of intersection. All right, the reason for that is going to become clear as we progress. So y is equal to x squared. This is one of the graphs or one of the curves. Also, because at the point of intersection, the x and the y values are the same, I can use any curve to generate the y value. So I'm going to say when x is equal to 0, I'm going to get y is equal to 0 squared, which is also 0. When x is equal to 3, I'm going to get y is equal to 3 squared, which is 9. So 0, 0, and 3, 9 are the coordinates of the point of intersection of the two curves. And so the next thing we might want to do is to draw a sketch of the situation, so as to get a visual appreciation of what we're dealing with. All right, so the two curves are y is equal to x squared. We know that one very well. It's a parabola that is symmetrical about the y-axis, and the minimum value of y is 0. All right, so this is y. This is y is equal to x squared. The next curve looks like this. So also a parabola that is symmetrical about the x-axis. The two curves intersect at the origin, and they intersect at 3, 9. All right. Now, so this is the area or the region that is bounded by the two curves. All right. Important to note is that what we're generating this area enclosed by the two curves. This time not about the x-axis, but about the y-axis. Now, the volume of solid of revolution, when you rotate a curve, an area about the y-axis is given by this formula: V is equal to pi, the integral from a to b of x squared dy. All right. So in other words, in order for us to get the answer, we need to express x in terms of y. We need to express x in terms of y, and then whatever we get, we need to square it. All right. So our first curve is the two curves are y is equal to x squared, and the next curve is y squared is equal to it's what, 27x. All right, so we need to express so for the second one, it's x is equal to y squared over 27, and so our volume V would be equal to pi, the integral from 0 to 9. These are your limits, 0 here and y here, 0 to 9 of x squared, and x squared is equal to y, so it's y dy minus pi, the integral from 0 to 9 of x squared, which is y squared over 27 square dy. All right, now of course we're going to do this one at a time, one piece at a time. So we have volume V is equal to pi, the integral from 0 to 9 of y dy, which should be equal to pi, and we have y squared divided by 2, and this is from 0 to 9. So the volume here would be equal to pi. We're going to first replace 9 with y with 9. So this is 9 squared over 2 minus 0 squared over 2. And this should be equal to pi into pi times 81 over 2. Pi times 81 over 2. So our volume V would be equal to 81 over 2 pi cubic units. All right. So let's get to the next integral. So our next integral is the integral from 0 to 9 of y to the 4th power over 27 square over 27 square, and I'm integrating this pi out to the front with respect to y. So this becomes pi over 27 square, the integral of y to the 5 over 5. All right. All right, from here, let's integrate. We have y to the 5th power over 5, and our limits are from 0 to 9. This is going to be equal to pi over 9 square times 3 square. First, replace y with 9, so this is 9 to the 5th power over 5 minus 0 to the 5th power over 5. So this is 0, so we don't have to think about it again. So what we have here is pi over 9 square times 9 multiplied by 9 to the 5th over 5. So 9 square times 9 is 9 cubed. So 9 cubed goes into 9 to the 5th. 9 square times 9 square is 81. So what we have is 81 over 5 pi cubic units. All right. So what we've just calculated is we've just calculated the volume of revolution of the area under the two curves within the limits from y is equal to 0 and y is equal to 9. We've done that. Now to get the volume that is generated by the area between the two curves, I have to subtract the two volumes. So that volume V would be equal to 81 over 2, I think, pi minus 81 over 5 pi, the LCM being 10. 2 into 10 is 5, so it's 5 times 81 pi minus 5 into, this is 2 times 81 pi. So the volume V would be equal to 3 times 81 pi divided by 10. So our final answer is 243 divided by 10 pi cubic units. All right. So in this question, one of the things that was very, very important to note is that we're not rotating about the x-axis, we're rotating about the y-axis, and therefore the limits had to be y values, and the two limits were y is equal to 0 and y is equal to 9. And that because we were rotating about the y-axis, the volume of the solid revolution would be given by this formula, a to b of x squared dy. All right. So all we have to do is be careful when we're reading our questions, so that we note carefully what we are doing, what we are being asked to do, so that we can execute and get it done correctly.